Welcome to this video. In this video, we are going to be doing some complex calculations in logarithms. Why do I call it complex? Because these calculations involve a combination of the several operations we've learned in our last video. We've learned about multiplication, we've learned about division, we've learned about powers and roots. But sometimes you can have some questions that involve a combination of more than one or two of these operations. Alright, so in this particular video we are going to be solving some examples that involve a combination of the different operations we've done so far using our logarithm tables. Now for this first question, this is the question we are told to solve. We are told to use our logarithm tables to solve for this. Alright, and then we are also going to solve this times 246.9 all over 256.2 times 3.28. Alright, so let's take it one at a time. Now this question tells us to use logarithm tables to find the third root of 218 divided by 3.12. Alright, now if you look at this question, what operations are here? That's the first thing you want to ask yourself. We can see a divided by, so there's a division operation. You can see a cube root sign, alright? So there's also a roots operation. No problem. Let's go ahead. Alright? So the first thing we want to do is draw a table of number and logarithm. Alright? So when we do that, let's figure out our mode of operation. Out of everything here, which is the first number we're writing? Don't forget, this is a root, so we cannot write it. Just we cannot start with a division. Alright, so we have to start with the first number. What are the numbers? 218 and 3.12. Which one should I start with? Obviously, common sense will tell you to start with the one at the top. So we are going to start with the one at the top, which is 218. Alright, so when you write that 218, you are going to look for its logarithm. The logarithm of 218 is 2.3885. And then we can now move on that, right? So we are basically taking care of everything here first. Everything here. After that, we can take care of the cube root sign. So divided by, when numbers are dividing, their logarithms will subtract. Don't forget. So divided by what? 3.12. I'm also going to look for the logarithm of 3.12. And the logarithm of 3.12 is 0.4942. Alright? So what does this mean? I'm going to subtract. When I subtract them, I'm going to have 1.8843. So this is the final answer for 218 divided by 3.12 in logarithms. What do you think? Should we convert now from logarithms back to number? The answer is no, not yet. Why? Because we have not finished solving all the operations. So we need to still solve for this cube roots operation before we can then know we are done solving and our final answer in logarithm we can convert it. I hope that makes sense. So we don't want to be in a hurry to just convert. In our previous examples, we always convert here because there's no other operation. We'll finish dividing, we'll convert. We'll finish adding the power, we'll convert. But now we are working with more than one operation. So we have to take care of all the operations: addition, multiplication, powers, division. When we are finished taking care of all of them, that's when we can convert. So for now, we've only done this division. So when we divide, when we did the division operation, this was the answer in logarithms. So let's still work in logarithms. Now, the next operation is to cube root everything here, 218 over 3.12, right? But this whole thing, we have solved it already, right? And we got it as 1.8843. So this is the same thing as telling us to cube root this 1.8843 because we solved all of it already. So when you are looking for the roots of a number, what happens to the logarithm? The logarithm divides by 3. Alright? So you're going to divide this by 3, so to say. 1.8843 divided by 3. And when you do that division operation, you are going to have 0.6148. At this junction, you have taken care of both the division operation in the question and the roots operation. You have gotten your final answer in logarithm. Now, can we convert? Yes. Yes, we can, because there's no other operation to take care of. So when you use your anti-logarithm tables to convert the final answer in number, you're going to have 4.119. That's your final answer. I hope this makes sense. Alright, so always make sure that you have taken care of all the operations before you convert to a number. Now let's move to another example. So let's look at the second example. This one is a bit long, but we'll also be able to solve it. Now we have two numbers multiplying at the top, two numbers multiplying at the bottom, and then the answers are dividing each other. How do we go about it? It's simple. When you have questions like this, where you have a numerator and a denominator, then the numerator has some operations to work with. The denominator has another operation. Please take them one at a time. That is, take its numerator at a time, then denominator at a time. So you can actually write it here, somewhere here, that this is the numerator you are working on. Alright? That everything above here is your numerator. And then for the bottom side is the denominator, so that you don't confuse yourself. So everything I'm going to write here is my numerator, and everything that is going to be here is my denominator. So for the numerator, I have 17.83 times 246.9, right? I'm going to put it here. 17.83, I will find the logarithm. The logarithm is 1.2511 times, which is what? Plus 246.9. The logarithm of that is 2.39325. Alright? So you see, I'm performing just the numerator operations. What do? I'm going to add it up. When I add these two numbers, I have 3.6436. Good. So this is my answer for the numerator. Remember, am I going to convert it to a number? No, because I still have other operations to work with. I have not finished working with it. So I'm going to keep this aside. 3.6436. This is my numerator in logarithm. Now I will do the same thing for my denominator. For my denominator, I have 256.2. If I convert that, that is 2.4085 times, which will be plus 3.28. 3.28, when I find the logarithm of 3.28, I'm going to add 0.5159. So when I add this plus this, I'm going to have 2.9244. So this is my final answer for the denominator as well. Let me write it here, 2.9244. So I've been able to simplify my numerator. Everything here, this is the value in logarithm, and everything here for the denominator, this is the value in logarithm. So what are the numerator and denominator doing? Basically, I have this is dividing. If this is A is dividing B, right? So if the numerator and the denominator, the two of them are dividing, what happens to their logarithms? You got it. Their logarithms will subtract. So I simply need to subtract this, the denominator from the numerator. And when I subtract the two of them, I'm going to be left with 0.7192. At this point, I have finished all the operations here. There's no more operation, no more division or multiplication to take care of. This is my final answer in logarithms. Can I convert now? Yes. There's no more operation to perform. So if you convert this to an anti-logarithm, the final answer you are going to get is going to be what? Now this is no longer the denominator. The final answer that you are going to get is 5.238. So that's my final answer. I hope that makes sense. So you just have to be careful, understand what you are doing before you start solving, not rushing to solve. Now let's take another example. Some questions always look complex, but if you understand it, it's very easy. Look at example 3. Example 3 says we should use logarithm table to solve this. When you see this, it may look difficult. You can notice in this question, there is multiplication, there is division, there is a power, there is also a root. So this is a typical example of some complex calculations we can do in logarithm. But the solution is always the same. What's the first step? We want to draw our number, alright, and logarithm table. Alright? So drawing this number and logarithm tables, as I've explained earlier, we are going to take care of our numerator. Alright, I'm going to see if the space will let me work. If it doesn't, I'm going to extend it. And so this is the space for our numerator. Alright, this is where we are going to be solving our numerator. And this is for our denominator. So for the numerator, we have some numbers, right? Permit me to shift this a bit upwards. Alright, so this is the number, and this is the logarithm. So for the numerator, we have this first number, 36.12, right? I know it has a power, but as we've learned, always find the logarithm of the number first, so you don't confuse yourself. So 36.12 is going to give me 1.5577. That's the logarithm. Now, if I should now cube it, 36.12, because of space, I'm supposed to write it again and then put the cube, but because of space, let me do it well here, the same place. So when I cube it, if I'm going to multiply it by power of 3, what will happen to the logarithm? The logarithm is going to multiply it by 3. Alright, we've done that before. If you multiply it by 3, you're going to have 4.6731. So we'll finish solving this in logarithm. We have times, which means this that we've got in here, plus, we are going to add it, plus something, 750.9. This one is straightforward. So when you look for the logarithm of 750.9, you are going to have 2.8756. So the two of them, since this is times, this is plus, they are going to add. Alright? So when you add the two of them, you are going to have 7.5487. So that is what you get for the numerator. 7.5487. Now what about the denominator? This is the first number here, 113.2. When you find the logarithm, you are going to have 2.0539. Now, 113.2 squared, when you square it, alright, when you square it, it means you are going to multiply it by 2, alright? Always multiply the logarithm by the power. When you multiply it by 2, you are going to have what? 4.1078. Alright? This answer we got for the numerator, permit me to shift it here so that we know this is our final answer for the numerator. Now, let's continue for what we are doing for the denominator. We've solved this first part. Times, which means plus root 92.5. So we'll write 92.5 first and we'll find the logarithm. Always write the number first. The logarithm of 92.5 is 1.9661. Since it is a root, of course, you know this is the same as square roots, alright? It means this is going to be divided by 2. So anytime they do not put number inside here for you, don't need to wonder, is it third root, is it fourth root? Just know it's square roots. So you are going to divide it by 2, alright? So dividing this by 2, you are going to have 0.9831. Now, they are multiplying, right? These two numbers are multiplying. So what will happen to the two of them's logarithms? They are going to add. So when you add the two of them together, you are going to have 5.0909. Alright? So this is the final answer for the denominator. 5.0909. So we've gotten the numerator and we've gotten the denominator. Now what are the two of them doing? The numerator, that is everything at the top and everything at the bottom. They are dividing. So since they are dividing, numerator is dividing the denominator, their logarithms are going to minus or subtract. So I'm going to subtract this denominator from this. That is 7.5487 minus 5.0909. When you subtract, you are going to have 2.4578. And that's your final answer in logarithms. Then you use your anti-logarithm table. When you convert this with anti-logarithm table, you are going to have 286.9. That's your final answer as a number. So that is it. How did you find it? Is it interesting? Is it exhausting? When you understand the processes, you take it step by step. Always work on the numerators first. Break everything down and keep your final answer for the numerator somewhere. Then you go to the denominator, break it down one by one, alright? And then you keep your final answer. and then since they are dividing, you can easily subtract them. So that is how to perform some complex operations in logarithms. Alright, so I'm going to be giving you some examples that I feel at this point in time you should be able to solve. Alright, so solve these examples for me and let me know the answers you got. Alright, so can you try this? And the first one is Alright, I think one example is going to be enough. Now, do not forget, always take care of the numerator first, and then whatever you get, take care of. You are going to get the final answer in logarithms. Let's say you get x. When you take care of the denominator, you are going to get y, and then you can subtract them and use anti-logs to convert your answer to a number. Thank you very much for staying to the end of this video. See you guys in my next video.